30 vehicles, 6 nations, every extreme condition Earth could throw at them. Siberian winters, Sahara heat, Pacific humidity, Russian mud. Some were engineered masterpieces that conquered the impossible. Others failed miserably. This is every vehicle built for extreme conditions in World War II. Let's begin with the Soviet Union, the masters of winter warfare, T-34, the tank that conquered winter. Designed specifically to dominate the Russian climate, the T-34 featured wide tracks that distributed weight over snow and mud, a diesel engine that started in freezing temperatures when German gasoline engines froze solid, and sloped armor that deflected shots while shedding ice and snow. Its simple, robust construction meant crews could perform field repairs at 40 below zero with frozen fingers, and its Christie suspension absorbed the punishment of frozen ground that shattered the tracks of more sophisticated designs. KV-1, the breakthrough colossus. Weighing 45 tons with armor up to 90 mm thick, the KV-1 was designed to smash through fortified positions regardless of weather or terrain. Its wide tracks prevented it from sinking into the spring mud that immobilized lighter German tanks, and its massive weight provided stability on ice that other vehicles couldn't match. Early in the war, single KV-1s held off entire German divisions, their thick armor impervious to German anti-tank guns, while their crews fought in conditions that would have killed soldiers in lesser machines. KV-2, the mobile bunker. Mounting a massive 152 mm howitzer in a turret that resembled a small building, the KV-2 was designed to demolish Finnish bunkers during the Winter War. Its enormous weight and low ground pressure allowed it to traverse deep snow and frozen swamps, though the massive turret became a liability when mud froze around the turret ring, jamming the traverse mechanism. Despite this vulnerability, it could obliterate fortifications with single shots, providing the Red Army with mobile siege capability in the harshest conditions imaginable. IS-2, the heavy tank perfected. Learning from the KV series weaknesses, the IS-2 featured improved weight distribution, better engine cooling for extreme temperatures, and a 152 mm gun that could destroy German Tigers and Panthers. Its designers incorporated years of experience fighting in Russian winters, adding engine preheaters, improved track designs for deep snow, and simplified maintenance procedures that soldiers could perform in blizzards. It represented the culmination of Soviet heavy tank development, a machine truly built for the Eastern Front's brutal reality. Su-76, the miniature survivor. Though lightly armored and nicknamed Bitch by its crews for its exposed fighting compartment, the Su-76 was designed for Russian conditions from the ground up. Its lightweight chassis prevented it from bogging down in spring mud. Its simple construction meant village workshops could repair it, and its open top actually became an advantage in summer heat when enclosed vehicles became ovens. Produced in massive numbers, it provided mobile artillery support that could follow infantry through conditions that stopped heavier vehicles. ISU-152, the Beast Slayer. Mounting the same 152 mm gun as the KV-2, but in a low-profile, fully enclosed casemate on an IS tank chassis, the ISU-152 corrected all the earlier design's flaws. Its weight distribution allowed it to navigate the Rasputitsa mud season. Its enclosed fighting compartment protected crews from the elements, and its devastating gun earned it the nickname Beast Slayer for its ability to destroy German heavy tanks. Soviet designers had learned that extreme conditions required not just power, but reliability and protection from the environment itself. While the Soviets mastered the frozen wasteland through purpose-built designs that embraced their homeland's brutal climate, Germany's panzers would face these same conditions from the opposite side, their sophisticated engineering meeting a reality for which they were never prepared. Panzer II Auersef. F. The Desert Improvisation. Originally designed for European warfare, the Panzer II underwent desperate modifications for North Africa's extreme heat and Russia's brutal cold. Engineers added tropical air filters to prevent sand from destroying engines, modified cooling systems that constantly overheated in 50°C desert temperatures, and winterized variants with improved heaters and track designs for snow. Despite these adaptations, the thin armor and light 20 mm gun meant it could only serve in reconnaissance roles, demonstrating that retrofitting existing designs for extreme conditions was never as effective as purpose-built machines. Panzer III, the adaptable workhorse. Designed as Germany's primary tank fighter, the Panzer III saw service from the burning sands of North Africa to the frozen hell of the Eastern Front. Its relatively simple mechanical design allowed field modifications for different climates, including tropical cooling systems, winterization kits with engine preheaters, and wider tracks for snow and mud. However, its narrow tracks compared to Soviet designs meant it frequently became stuck in the Rasputitsa mud that Russian tanks traversed easily. And its complex optics often froze solid in Russian winters, blinding crews at critical moments. Panzer IV, the survivor that learned. The only German tank to serve throughout the entire war, the Panzer IV evolved through painful lessons learned in extreme conditions. Early models in Russia had engines that refused to start below -30, tracks that broke on frozen ground, and turret mechanisms that jammed when mud froze overnight. Later variants incorporated wider tracks, improved winterization, better cooling for desert operations, and simplified maintenance procedures. Its evolution demonstrated that adaptability mattered more than initial sophistication when facing nature's extremes. Panther, the technical marvel's fatal flaw. Built to counter the T-34, the Panther was a masterpiece of engineering that suffered catastrophically in extreme conditions. Its complex interleaved road wheel design, packed with mud that froze solid overnight in Russia, immobilizing entire battalions by morning. The sophisticated transmission failed in dust, mud, and extreme temperatures with alarming regularity. Desert variants overheated constantly despite modifications. The Panther proved that advanced engineering meant nothing when a tank couldn't move, and crew manuals warned that operating in temperatures below -10 or above 30 Celsius risked mechanical failure. Tiger Siwin, the legend that demanded perfection. With its fearsome 80mm gun and thick armor, the Tiger I struck terror into Allied hearts, but it was never designed for the extreme conditions where it fought. Weighing 56 tons, it sank into mud that lighter tanks crossed, its narrow tracks providing insufficient ground pressure distribution compared to Soviet designs. In Russian winter, its complex steering system froze. Its Maybach engine required 2 hours of preheating before starting, and its sophisticated optics iced over. In North Africa, sand destroyed the precision-engineered components, and overheating plagued operations. The Tiger dominated when it worked, but extreme conditions kept more Tigers out of action than enemy fire ever did. But Germany's Axis partners faced even harsher realities with machines that were obsolete before they left the factory, forced to fight in conditions that exposed every design flaw with brutal clarity. M1340, the Italian disaster in the desert. Designed for European warfare, the M1340 was a catastrophe in North Africa's extreme heat. Its gasoline engine overheated constantly in temperatures exceeding 50 degrees Celsius, requiring crews to shut down every few hours to prevent seizure. The riveted armor cracked under thermal expansion, creating gaps that let sand infiltrate the fighting compartment and destroy mechanical components. Its narrow tracks sank into soft sand, and the underpowered engine struggled to move the tank through dunes. British crews called capturing them a liability because they broke down more often than they fought, proving that some tanks simply couldn't survive extreme conditions, no matter how brave their crews. M1441, the failed improvement. Italy's attempt to fix the M1340's problems resulted in the M1441, which featured a slightly more powerful engine and improved cooling. However, it still overheated in desert operations, the armor remained inadequate, and the 47mm gun couldn't penetrate British tanks. The mechanical reliability improved marginally, but crews reported that sand still destroyed engines within weeks of operation. It represented Italy's inability to produce tanks capable of surviving the extreme environments where they were forced to fight, and most were destroyed or abandoned during the North African retreat. Semovente, 75 or 18, the only Italian success. By mounting a 75mm howitzer in a low-profile casemate on the M13 chassis, Italy accidentally created a vehicle that could survive desert conditions. The enclosed fighting compartment protected crews and mechanisms from sand, the lower profile reduced heat absorption, and the simpler design meant fewer components to fail. While still suffering from overheating and mechanical issues, it proved more reliable than Italian tanks and could actually engage British armor effectively. It demonstrated that simplification and protection from the environment mattered more than sophisticated design. Type 95 Heigo, the jungle lightweight. Designed for Japan's campaigns in China and the Pacific, the Hago was optimized for jungle warfare with narrow dimensions that could navigate jungle trails and lightweight that prevented it from sinking into soft ground. However, its thin armor could be penetrated by heavy machine guns, and the humid tropical climate caused constant rust and mechanical failures. The crew compartment became an oven in tropical heat, with temperatures inside exceeding 60 degrees Celsius. Against American tanks in the Pacific, it was hopelessly outmatched, proving that being designed for jungle conditions wasn't enough when facing superior enemy armor. Type 97 Chiha, the backbone that couldn't compete. Japan's primary medium tank featured a low-velocity 57mm gun, excellent for destroying bunkers in China, but useless against American armor. The tropical climate corroded components rapidly, and the gasoline engine was vulnerable in jungle ambushes. Its thin armor meant that American 37mm guns could penetrate it easily, and crews reported that the intense heat and humidity inside the tank was as dangerous as enemy fire. The Chiha was designed for infantry support in moderate climates, not the extreme tropical conditions where it fought. Type 97 Shinhodo Chiha, the desperate upgrade. After disastrous encounters with Soviet tanks at Nomonhan and American armor in the Pacific, Japan upgraded the Chiha with a high-velocity 47mm gun. While this improved its anti-tank capability marginally, it did nothing to address the fundamental problems of thin armor, mechanical unreliability in tropical conditions, and crews suffering from extreme heat. The upgrade demonstrated Japan's recognition of the problem, but inability to solve it with limited industrial capacity. Type 1 Chi-Hei, the tank that arrived too late. Japan's attempt to create a true medium tank resulted in the Chi-Hei, featuring welded armor, better crew ergonomics, and improved mechanical reliability. However, it arrived in 1943 when American armor had already surpassed it, and most were held back in Japan for the invasion that never came. Its better cooling systems and rust-resistant components showed Japan had learned from tropical warfare, but the lessons came too late to matter. Type 2 Kami, the true amphibious innovator. The only vehicle in this catalog genuinely designed for extreme amphibious conditions, the Kami featured detachable pontoons that allowed it to swim from ships to shore, then fight as a light tank after jettisoning the flotation devices. Its sealed hull protected against saltwater corrosion, and the crew compartment could be pressurized for shallow river crossings. While lightly armed and armored, it succeeded at its specific extreme condition mission, proving that purpose-built designs for specific environments could work even with limited resources. Unfortunately for Japan, few were produced and most were destroyed before reaching combat. While the Axis minor powers struggled with inadequate machines and brutal environments, the Western Allies flooded every theater with vehicles that succeeded not through superior design for specific conditions, but through adaptability, mass production, and the ability to fight anywhere. Char B-1 Bis, the French fortress that couldn't adapt. With thick armor and a powerful 75mm hull gun, the Char B-1 Bis was a formidable tank in 1940, but its design predated the concept of fighting in extreme conditions. The complex steering system required precise maintenance that field conditions made impossible, the gasoline engine was vulnerable and consumed fuel at alarming rates, and the single-man turret made crew coordination difficult in the chaos of battle. When France fell, Germany captured hundreds and used them in Russia, where they promptly broke down in conditions they were never designed to handle, proving that pre-war design philosophy couldn't survive modern warfare's extreme demands. Somua S-35, the cavalry tank with fatal flaws. Considered one of the best tanks of 1940, the Somua featured excellent armor and a capable 47mm gun, but its cast armor, construction created weak points, and the one-man turret limited effectiveness. More critically, it required specialized maintenance that frontline conditions didn't allow. and mechanical complexity meant that extreme cold or heat caused frequent failures. Like the Char B-1, captured examples used by Germany and Russia demonstrated that elegant pre-war designs couldn't compete with purpose-built machines for extreme warfare. Matilda II, the infantry tank in the desert. Britain's heavily armored infantry tank found unexpected success in North Africa, despite never being designed for desert warfare. Its thick armor was nearly impervious to Italian and early German tanks, and the reliable engine performed adequately in heat. However, its slow speed made it vulnerable to flanking, the cooling system struggled in extreme temperatures, and sand infiltration caused constant mechanical problems. It succeeded in Africa not because of superior design for desert conditions, but because British maintenance capabilities kept it running when Axis tanks failed. Valentine, the reliable workhorse everywhere. Designed as a cheap infantry tank, the Valentine became Britain's most produced tanks by accident of timing and proved remarkably adaptable to extreme conditions. Its simple mechanical design allowed field repairs in any climate. The compact size meant it could be shipped efficiently to any theater, and crews reported it was one of the most reliable tanks they operated. Sent to Russia via Lend-Lease, Soviet crews praised its reliability in conditions that destroyed more sophisticated designs, though they complained about its weak gun and cramped interior. Crusader III, the Desert Racer. Designed specifically for the North African campaign, the Crusader prioritized speed over armor with a powerful engine and light weight. However, the same engine that provided 40 miles per hour speed also overheated constantly in desert heat, and the thin armor made it vulnerable to German anti-tank guns. Sand destroyed the cooling system with regularity, and mechanical breakdowns were so common that British units required extensive recovery capabilities. It demonstrated that designing for one extreme condition, speed in the desert, created vulnerabilities to others, mainly heat and dust. Churchill MiG-7, the mountain climber. Initially designed as an infantry tank for European warfare, the Churchill accidentally became excellent for extreme terrain through its long chassis and multiple small road wheels. In Italy's mountains, it could climb slopes that stopped other tanks, and its track design provided excellent traction in mud. Though slow and initially mechanically unreliable, later variants proved capable of operating in almost any terrain, from the deserts of North Africa to the mountains of Italy to the mud of Northwest Europe, becoming one of Britain's most versatile designs. Cromwell, the speed demon, refined. Learning from the Crusaders' failures, the Cromwell balanced speed with reliability through a powerful Meteor engine derived from aircraft designs. It could reach 40 miles per hour while maintaining mechanical reliability that the Crusader lacked, and improved cooling systems handled various climates better. However, its armor remained relatively thin, and the high speed was often useless in the close terrain of Northwest Europe. It proved that extreme speed wasn't always necessary when reliability and adaptability mattered more. Comet, the refinement perfected. Britain's final wartime cruiser tank combined the lessons of all previous designs with a powerful 77mm gun, improved armor, and excellent mechanical reliability. It could operate effectively in the cold and mud of late-war Europe, and its design incorporated years of experience fighting in extreme conditions. Though arriving late in the war, it represented what British tank design could achieve when extreme condition experience was built into the design from the beginning rather than adapted afterward. M3 Stuart, the Scout everywhere. America's light tank served in every theater from the Pacific jungles to Russian snow to North African deserts. Its radial aircraft engine was reliable but noisy, making it easy for enemies to locate, and its 37mm gun was inadequate against most Axis tanks by mid-war. However, its mechanical simplicity meant it could be maintained in any climate, and crews appreciated that it reliably started and ran when more sophisticated designs failed. It succeeded through dependability rather than excellence in any specific extreme condition. M3 Lee Grant, the stopgap in the desert. With its unusual design mounting a 75mm gun in a hull sponson and 37mm in a turret, the Lee was never intended for extreme conditions, but found itself fighting in North African heat. The high profile made it an easy target. The riveted construction meant hits could send deadly rivets flying inside the crew compartment, and the complex configuration confused crews. However, its powerful 75mm gun could engage German tanks effectively, and American mechanical reliability meant it worked when Italian tanks failed, demonstrating that basic reliability could overcome design compromises. M4. Sherman, the tank that fought everywhere. If any single tank proves the value of adaptability over specialization, it's the Sherman. It fought in Russian snow at -40, North African heat at +50, Pacific jungles with 100% humidity, European mud, and Italian mountains. It wasn't the best tank in any single condition. German tanks had better armor and guns. Soviet tanks handled mud better. But it worked reliably everywhere. Its simple maintenance, available spare parts, and crew comfort meant it could fight continuously in conditions that sidelined more sophisticated designs. The Sherman succeeded because it was built to be repaired and operated anywhere rather than excel in one specific extreme environment, and American logistics kept tens of thousands running simultaneously across the globe. From the frozen steppes of Russia to the burning sands of North Africa, from Pacific jungles to European mud, these 30 vehicles weren't just built for war, they were tested in the harshest conditions Earth could throw at them. Some triumphed through brilliant engineering, like the T-34's wide tracks for snow. Others succeeded through sheer numbers and adaptability, like the Sherman fighting everywhere. And some failed miserably, like the M13/40 melting in African heat. The extreme conditions of World War II proved that the best tank wasn't the one with the thickest armor or biggest gun. It was the one that kept fighting when nature itself became the enemy. Which one would you trust your life with?